Hey guys, Dr. Brown here again with Kubo Math coming to you from Tarlac City, Philippines. So tonight we're looking at Algebra 2 with a review of everything we've just done through Chapter 1 or Section 1. So we have three different categories. We're going to look at reducing, factoring, and then actually solving some of the equations. So let's get after it. Let me do a little housekeeping here. Okay. 5x minus 7x. If we were to reduce that, you'd say, well, 5x minus 7x is minus 2x. That's true. If we were to use, though, the inverse of the distributive rule, what would it look like? So if I factor out the x, and that would be x times 5 would give me 5x, minus x times 7, which would give me 7x. So we could algebraically take and undo the distributive rule, take it in reverse. 5 minus 7 is negative 2 times x, which gives me negative 2x. Okay. What about this one? How would we reduce this? We also have a distributive law here, or distributive rule, that if I want to take the parentheses away, I need to distribute the negative to the inside. So this is like a negative 1 setting here. So a negative 1 times, let's see, 2x minus 1 times 5x. I'm stumbling over my speech here. So minus 5x. And then a negative times negative is positive 7. So negative 1 times a negative 7 is a positive 7. So now 2x minus 5x would be negative 3x plus 7. Okay, so that's our answer here. Now we could have factored the x out, same as we did here. We could have gone about it in that way. Now this one, negative 2x to the parentheses of negative 2x to the second power minus 2 times x to the second power. Now what's in this parentheses is multiplied by itself 2 times. So it's telling me I have negative 2x times negative 2x minus 2 times x to the second power. So you recall in one of the other videos, when we're multiplying or adding, we can only multiply like items. So I have my pakwan, my saging, and my papaya. So my pakwan times my pakwan here. You get the idea. Negative times negative is a positive. 2 times 2 is 4. X times x is x to the second power. So positive 4x to the second power minus 2x to the second power. Now I could factor the 2x out, but just keep it 4x to the second power minus 2. 4 of these minus 2 of them gives me 2x to the second power. Okay. All right. Not too difficult there for our reductions. Now then, let's factor some of these. 2x to the second power plus 8x plus 6. I always would encourage you when I write a problem down and say, well, we're going to factor this or perform some mathematical function, I would encourage you to just pause the video and try that on your own. Try to work that out. Try to exercise your mind and see if you can do that. Okay, we can factor a 2 out, so let's do that. 2 times x to the second power plus 2 times 4x gives me 8x, and then plus 2 times 3 gives me 6. So 2x squared plus 8x plus 6. Okay, now then, we'll leave our 2 to the outside. Put our little grid on this guy. Okay, the factors of 3, not too much I need to do there, besides it's 3 and 1, it's prime numbers. And they're positive, so these could be negative and negative, or positive and positive, but since they're adding up to be a positive 4, I know that's a positive 3 and a positive 1. Okay, the factors of x to the second power are x times x. Recall my 2 is outside here. X times x. Okay, so 3 times x is a positive 3x. 1 times x is a positive x. 3x plus x is a positive 4x. X times x is x to the second power. 3 times 1's positive 3. So that's what I needed to give me this. So now I have x plus 3 and x plus 1. My x had fell over. X plus 1. Okay. All right, so that gives me x squared plus 3x plus 1x is 4x plus 3. All right. So x plus 3 times x plus 1. Okay. Hey, we're rolling. We are rolling now. Oh, and I should have put the 2 times that, so don't forget the 2. Okay, let's see. We got those. Now then, let's factor this guy. 3x to the second power minus 30x plus 75. All right, let's factor, we can factor a 3 out. 3 times x squared. Let's see, 3 times a negative 10x gives me a negative 30x. And 3 times 25 gives me 75. So let's factor this guy. Oh, I can already see this one. Okay. 5 times 5, negative 5 times negative 5 gives me a negative or a positive 25. Negative 5 plus negative 5 gives me a negative 10. So x times x, oh, and this time don't forget my 3 out here. I better write that guy down so I don't forget it. Okay. Here we go. All right, so negative 5x, negative 5x, oh, x minus 5, and x minus 5. So what does that give me? 3 times x minus 5 to the second power. This times itself 2 times. Okay. Everybody good so far? Hopefully you paused, tried these on your own. On the other one, hopefully you were screaming into the monitor going, ah, you forgot the 2. I am human, more human than most. All right. 8x plus 27 equals 5x. Well, I have x's on both sides, so let me collect those. So 8x minus 5x plus 27 equals 5x minus 5x. I've subtracted 5x from both sides. So 8x minus 5x is 3x plus 27 equals 0. So now 3x, I'm going to subtract 27 from both sides. 3x plus 27 minus 27 equals 0 minus 27. So the 27's cancel. 3x equals minus 27. I don't want 3x's, I want 1x, so let me divide both sides by 3. 3 divided by 3 is 1. 1 times x is x equals negative 9. So that's not so bad. Okay. And let me check them off as I go. Oh, here's a good one. 2x, the absolute value of 2x plus 5 equals 9. Now, if I have a number line here, and here's 9 and here's negative 9, the absolute value of negative 9 is 9 because it's 9 units from 0. The absolute value of a positive 9 is 9 because it's 9 units from 0. So what that means is 2x plus 5, it could equal a negative 9, and then 2x plus 5 could equal a positive 9. So now I need to solve for x in both of these because those are potential solutions. So 2x plus 5, I'm going to subtract 5 from both sides, equals negative 9 minus 5. So the 5's cancel. 2x equals, so minus a positive is plus a negative, so that's minus 14. So divide by 2, that cancels. X equals minus 7. Okay. Now subtract 5 from both sides again. So plus 5 minus 5 equals 9 minus 5. The 5's cancel. 2x equals 4. 9 minus 5 is 4. So I need to isolate the x. 2 divided by 2 is 1. 1 times x is x. 4 divided by 2 is 2. So 2 times 2 is 4. 4 plus 5 is 9. Okay, that absolute value of 9 is 9. 2 times negative 7 is negative 14. Negative 14 plus 5 is a negative 9. The absolute value of a negative 9 is 9. So my two solutions, x could equal negative 7 or x could equal 2. So that's a nice little absolute value problem. All right, let's see what else we have here. Oh, this is kind of cool. This is an inequality. I guess I say it's kind of cool a lot. I just think exercising your mind is just a good thing to be doing. And when I first saw this problem, it just jumped out at me as, oh, but it was a little bit unique in the fact that we've been solving these quadratic equations, these polynomials of first and second order, by factoring them and getting them into two parentheses multiplied together that are equal to 0. And in this case, it's greater than 0. So it's a little bit unique. So having said that, we have a number line here. I've got 0, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. Okay. All right. Let's act as if this is equal to 0. We'll just go at it that way for a moment, just as we did in the previous videos. If that's the case, this one has to equal 0, or that one has to equal 0 in order to get an answer that equates to 0, because if this is positive and this is positive, then that answer is positive. Okay? So, but which would be okay. If this is negative, that's negative, well, that's positive. That's okay. But what if this is positive, this is negative, or this is negative and that's positive? Both of those would end up being negative. So there's some potential areas of that number line that are not solutions. So let's assume it equals 0 and solve. So x would equal 0. 0 times anything would give me 0. But x plus 3, if that equals 0, then x plus 3 minus 3 equals 0 minus 3. So that these 3's cancel, x equals negative 3. So negative 3 plus 3 equals 0. All right, what does that mean on my number line? X cannot equal 0, so I'll put a circle, not a big dot, but a circle indicating that the answer can get close to 0, but it cannot equal 0. Same with negative 3. I'm going to put a large circle there. It can approach negative 3, but it cannot equal that. So it tells me I have 3 regions here. So greater than 0, and this less than 0, but greater than negative 3 region, and then less than negative 3 region. So let's plug those in and see what happens. Okay. So if I plug those in, I have a negative 4, let's say, and negative 4 plus 3. So this negative 4 obviously is negative. Negative 4 plus 3 is a negative 1. So negative times negative is a positive. So that's okay. Numbers out here are okay. All right, what about in this region? Let's say negative 2. So I have a negative 2, and then a negative 2 plus 3. So this is negative. Oh, but that's positive. Positive times a negative gives me a negative. That's bad. Okay. And now then, clear out a little room here. What about in this region? Let's say the number 1. So I have 1, which is positive. 1 plus 3, which is 4. Well, that's positive. Positive times positive gives me a positive. So this region is okay also. So what does that mean for X? Well, X can be less than a negative 3. So it can be anywhere down here. X can also, or X can be greater than 0. So it can go all the way to infinity. This one can go from less than negative 3 all the way down to infinity also. So those would represent the range of solutions for that inequality. Okay. One more to go. One more solution. This will be our quiz for the day. Okay. X to the second power minus 9x plus 20. We want to, let's say that equals 0. Let's solve for x. All right, so I can factor. I need factors of 20, positive 20, that when I add those factors together give me a negative 9. Of course, I know this is x times x. Okay, 5 and 4. 5 times 4 is 20, but they end up being negative, and this is positive, so this would be negative times negative. Negative 5 times negative 4 is a positive 20. Negative 5 plus negative 4 is a negative 9. So I'm good to go. Negative 5 times x, negative 4 times x. Add those together is negative 9x. X times x is x to the second power. Negative 5 times negative 4 is positive 20. So I have x minus 5 times x minus 4. And that equals 0. So that means this parentheses can equal 0, or this parentheses can equal 0. So 5 minus 5 would be 0, so x equals 5. 4 minus 4 would also equal 0, so x could equal 4. So let's challenge ourselves here. 5 squared is 25. 9 times 5 is 45. So 25 minus 45 is minus 20 plus 20 equals 0. That works out. Okay, let's try the 4. So 4 to the second power is 16. 9 times 4 is negative 9 times 4 is negative 36. 16 minus 36 is a negative 20. Negative 20 plus a positive 20 equals 0. So these were 9 problems that worked out pretty good. So hopefully you like these. This would be the end of chapter 1. And we're going to be stepping into some new material here shortly. So go back, study the rules, study the material that we've already laid out and gone through for Algebra 2. So we had equalities, inequalities, we had the cumulative, the associative, the distributive properties, we had inverses for addition, inverse for multiplication. We had all the rules, the positive and negatives, and working with those, which we did a lot of tonight. We did factoring, and we performed equation solving for x, again, same as we did tonight. So keep working on those, and then together let's build a better tomorrow, and let's do that through math, okay? Have a great evening, and we'll see you next time. Take care. Thanks.